Hey there, before we get started into reviewing some stuff, why don't you pause the video, do this, do now, and review how to solve this equation. So now that you've tried those out, hopefully you've tried those out, we're going to solve them. And so if you recall, the opposite of square rooting something is to square them. And so what we want to do with these problems is isolate the radical. And then when we do, we're going to square it. So we're going to square the radical and we're going to square whatever's on the right-hand side there. The nice thing about this is that the square root and the square will cancel each other out. So we do not have to worry about foiling on the left-hand side. We're just left with whatever is underneath the radical. In this case would be x minus 2. And on the right, we would square 7 squared to get 49, and then add 2 to get 51. Always check for extraneous solutions. This one is good to go because 5 minus 2 is positive. Same thing on the right-hand side. So the first thing we have to do is isolate the radical because there's a plus 9 on the left. So I'm going to subtract that from both sides. And what I end up with is the square root of x is equal to negative 7. There is no number that we could take the square root of and get a negative number because, again, it's an even index there. And so we don't have a solution here. All right, so I told you we were going to take a look at these problems from the packet yesterday that we didn't get to. So yes, I understand that they look kind of crazy, but we're just going to apply the rules that we already know. The only difference is we're going to be working with fractions as our exponents in some of these. And the new thing here is that we don't have any fractional exponents in the denominator. So in this first problem, what I like to do sometimes is combine everything that I've got inside before I apply the exponent of that 3. So that's what I'm going to do first. So m times m is m squared, n to the third times n is n to the fourth, and then p doesn't have anything to combine with. Then we would essentially take the 3 and distribute it through, because that's product of or power of a product. And so we distribute through, and we get m to the 6th, n to the 12th, and then p to the negative 3. And then anytime we have ourselves a negative exponent, we've got to move it down to, or move it to the opposite side. So in this case, it's going to move down in the fraction into the denominator. And that's all. Moving on here, same idea, but now we got some numbers involved. So again, I like to combine things sometimes. So 2 times 2 is 4. X and x to the negative fourth combined to give us negative 3. Z squared and z to the fourth gives us z to the sixth. The y squared has nothing to combine with. So then from there, I'm going to distribute through with that negative 3 to all the exponents, or yes, to all the exponents. Now 4 doesn't have an exponent, so it's just going to get the negative 3 versus the x, y, and z. We're all going to get multiplied. So I get 9 because 2 negatives make it a positive, negative 6, and negative 18. And then from there, I need to see that I have all these negatives that I need to make sure they're positive because we can't end with negative exponents. And so all of those are going to move into the denominator. And as I do that, the 4, I'm actually going to apply it to the third power. So 4 to the third power is 64. And then I'm going to bring the y and the z down. And that's finished. Last but not least, well, we've got 2 more problems that are going to be like these. They're not as bad as you might think. It might look intimidating, but like I said, we're just applying the same rules that we've done with whole number things. And all that has to happen is at the end, we can't end with a fraction. So here's the first thing I noticed. First thing I noticed is both of these things here have an exponent of 0. Anything to the 0 power is automatically 1, which makes this problem significantly smaller. So I'm going to take away all of those things, and I'm left with m to the 4/3, p, m to the 2/3, and n to the 5/3. So first thing we want to do, get rid of any of our 0 exponents, or you can distribute through and combine things together. So then from here, I notice that I have an m in the numerator and in the denominator. And just like if it was an m to the 4th over m squared, we would subtract the exponents. We're going to do the same thing here. So I'm going to do m to the 4/3, and I'm going to subtract 2/3 from it, and I'm left with 2/3. It's positive, so it's going to remain in the numerator. The p and the n have nothing to combine with, so we're going to leave it where they are. Now, what we have here is this n to the 5/3. This is what I was talking about where we can't have fractions in the denominator. It's the same idea as if we couldn't leave a radical in the denominator. Because remember, this is technically the cubed root of n to the 5th. And so since we have a cubed root of something, we need to make sure we're balancing it out and we're getting rid of that fraction in the denominator. So you have to think to yourself, in order to get 5/3 to become a whole number, I need to add something to it. And so you want to add a third of something such that when I divide by 3 in the end, it would divide to a whole number. So I see that the 5 is really close to 6. I just need one more third to add on to it. So what I'm going to do is multiply the top and the bottom by n to the 1/3. So then when I multiply up the top, I'm left with m to the 2/3 and n to the 1/3. Don't actually combine. But at the bottom, when I add those exponents, I get 6/3. And so this is what I was talking about as I was choosing a number over here for this, such that when I combine these two together, I would get a number that can be divided. So 6 divided by 3 is 2. Now you might be wondering, well, why can I have a number or a variable in the top and the bottom? So again, think back to rationalizing the denominators in the past. If you had something like the square root of x in the denominator, you would rationalize top and bottom. And in the end, you end up with square root of x in the numerator and an x in the denominator. So it's that same idea. This has a radical, this does not. And that's what our goal is for these problems. All right, last one we want to do is this one. Again, don't be intimidated by its size. It's just this exact same process. So what I'm going to do is distribute through with the -3/2. You could have combined these two r's together as well if you wanted to first, and then distribute through with the -3/2. So I'm just going to multiply all of those exponents. And so when I do, -3/2 times -1/3 is 3/6. And then I got -3/2, +3/2, +3/2. So then from there, I'm going to identify all of my like things in the numerator and the denominator. So what I see is I've got r to the 3/6, r to the -3/2, and r to the 7/4. I've got two of these p's here and two of these q's. So I'm going to apply those rules of doing the top number minus, or add these two together. So I got the 3/6 and the -3/2, and then I'm going to subtract 7/4. And what I end up with is -11/4. So what I need to do is put the 11/4 in the denominator. 3/2 minus 1 gives me 1/2. 3/2, and then I'm going to end up adding 5/4 to the top, gives me 11/4. And so what I have to deal with is this r to 11/4 in the denominator. Again, this is just combining all of our exponents together. Again, relate it back to our exponents with just whole numbers. It's the same process. I would put these two together and then subtract this. So I noticed that r to the 11/4 is not a whole number, so I need to think to myself, well, I need to get it to become 1, and so what I need to do is make that 11 into a 12. So I need one more fourth for my r. So I'm going to multiply top and bottom by r to the 1/4. So up top, I have p squared, q to the 11/4, sorry, not p squared, p to the 1/2, q to the 11/4, and r to the 1/4. In the denominator, I have 12/4, which allows us to get a 3, and that would be our final answer. Okay, so you're going to have a worksheet that's going to have some of these problems on there for you to practice, and then we're going to have some stuff with solving radicals. So let's get into that second half of the video here. You can fill out the notes as you go that you have been given, that's in front of all the practice worksheets, okay? So here's the steps that you always take. You isolate a radical, you square or cube or whatever it is, both sides of the equation, whatever the index is, do the opposite, and then simplify. If we still have a radical somewhere, then we'll repeat those steps. If not, then you're going to move on and solve. Don't forget to always check for extraneous solutions. So some of these might tend to get a little lengthy just depending on how many radicals we have. So here's our first problem. Okay, now note you can see it as like the cube root here, or I can have this 2x minus 3 in parentheses and I have an exponent of 1/3. So just keep that in mind. So what I want to do is isolate the radical. So the first thing I want to do is move my 2 over to the right, and I get a -3. Now it's okay to get a negative because I have an odd exponent here. So the opposite of cubing, or taking the cubed root, is to cube something. And so we're going to do the opposite here by cubing both sides. So like I said before, the nice thing about the radical stuff is that they're going to cancel each other out. And so I'm left with 2x minus 3. -3 to the third power is -27. And then from here, we're just solving an equation that you've done way back in Algebra 1. So I'm going to add 3 to both sides and then divide. Again, always check for your extraneous solutions here, but remember it's a cubed root, so any number can really be underneath our radical answer there, so we don't have any extraneous solutions here, and -12 does work. You can always plug it back in and check to make sure it works there. All right. Okay, so this is the same type of problem. Oops, sorry. There we go. So this is the same idea again, but there's a variable in here now. It doesn't make it any more different, but we always start by isolating the variable. So I'm going to move my 2x to the right-hand side, and I end up with -2x plus 8, or you can write it as 8 minus 2x. In the end, it doesn't really matter. So the opposite of square rooting something is to square it, so I'm going to square both sides. On the left-hand side, the square root and square cancel out. I'm left with x plus 1. But on the right, you're going to have to FOIL it out. And so when you FOIL, you end up with 4x squared minus 32x when you do outside inside, and then 8 times 8 is 64. So here's where you have to note that this is a quadratic. So you have to remember, if you see a quadratic, we're going to have to set this equal to 0 and solve. So I'm going to move my x and 1 over, and I end up with 4x squared minus 33x, and then plus 63. If you can factor it. This one is factorable. Remember, you can always check by doing b squared minus 4ac, and if you get a perfect square, it'll factor. So here we're going to factor. It factors into 4x minus 21 and x minus 3. Obviously, the process of factoring might take a little bit longer for you to do, and that's fine. But again, main idea here is that you're able to factor. So then we're going to set both of these equal to 0 and solve. So for the first x, you get 21 over 4, and the second x is equal to 3. Again, check for those extraneous solutions. These are good to go. All right, so for this last one here, we have the square root of 2x minus 4 minus the square root of 3x plus 4. You have an option of which one you want to isolate first. And so what I'm going to do is move the one that's highlighted in red over. The reason I want to do that is because I just want to bring that minus, make it a plus sign over here. We could have moved the 2x minus 4 over here if we wanted to, but then we have to make sure we would divide by the negative that's in front. So here's my process. I'm going to start by moving my 3x squared to 3x plus 4 over. Then just like before, we've isolated our radical, the opposite would be to square it. So I'm going to square both sides. Now on the left, nice and easy. Opposite of square root is whatever is the square, they cancel out. On the right though, we're going to have to FOIL. So when it FOILs, it's going to -2 times -2 is 4. Outside inside would give me two things of -2 times the square root of 3x plus 4, so I end up with -4 times the square root of 3x plus 4. And then the square root of 3x plus 4 squared, again, that's going to cancel. So we have 3x plus 4. So I'm going to still have a radical here. So what we want to do is isolate it. So what I'm going to do is kind of combine my like terms on the right. And I end up with 3x plus 8 because this 4 and 4 goes here. Then I'm going to move these two pieces here on the right, that plus 3x and plus 8 to the left. And so I end up with negative x minus 12. Then finally, I'm going to get this away from both sides by dividing both sides by -4. So what I end up with is 1/4 x plus 3, and that equals the square root of 3x plus 4. So then from here, I'm going to have to now square both sides just like we did. So we're repeating those steps, isolating the variable, squaring, and solving. So when I square both sides, on the left, again, you're going to have to FOIL. So I'm left with 1/16 x squared plus 6/4 x plus 9. And on the right, I get 3x plus 4. I like to get over fractions, as you know, so I'm going to multiply through by the common denominator of 16. Just make sure you're multiplying everything by 16. The reason I am allowed to do that is because of the equal sign. No equal sign, don't do that. So we're going to distribute through. I end up with x squared plus 24x plus 144. And on the right, I have 48x plus 64. Again, I have a quadratic, so we set it equal to 0. So when I move everything over, I end up with x squared minus 24x plus 80, which I can then factor, no problem. I got x minus 20 times x minus 4. So our two answers here are 20 and 4. Check your extraneous solutions. Both of these are good. So that means those are the correct answers. Why don't you try this one? I know that you're taking in a lot right now, but why don't you give this one a try? Okay, so let's see how you did. Again, we want to isolate it. So I'm going to move my x over, square both sides. I end up with x plus 1 equals x squared minus 10x plus 25. Set it equal to 0, factor, and solve. So we get the answers of 3 and 8. Both of those numbers are fine if you plug them back in. All right. I hope you're not too exhausted from everything we've gone over. So I'd like to tell you a joke. Did you hear about the circus fire? It was intense, but ching. But here's my favorite, all-time favorite. What's Beethoven's favorite fruit? Ba-na-na-na. Listen, I totally won a joke off with this joke. So don't mock my joke. Take a breather before we move on to the classwork. You've learned a lot just now. So just take a break and then come back to this. I will see you next week.